Last time on the Studio Design and Build mini-series, I arrived on location and checked out the site. Thomas and I discussed the goals and vibe of the room, and I came up with a plan that maxes out the potential for his space. Now, on to the next step. All right, it's time to spin this room around and get all the gear out. Let's go. All right, so we've got everything out of the room. We've got a clean setup, and we're gonna begin our baseline acoustic testing. But let's just listen to how loud and live the starting space sounds. Yep, sounds like a bare room to me. Let's get started on the acoustic test. So the closet is one of the things that is an acoustical cavity. It's its own chamber that can resonate with its own set of room modes that correspond to the dimensions of the boundaries in the closet. And in general, you don't want those in your test results. So we have damped this cavity with some acoustic materials that we had laying around. So Thomas used a combination of his old acoustic modules and popped them up there, a pillow. Basically, you can use anything in here that you have around. You could hang jackets if it's a closet, if that's what you have. You could use rock wool, fiberglass, or old acoustic modules, pillows, blankets, whatever you can do to damp the cavity. So you can see here, basically filled, and that's going to prevent it from resonating and throwing off our test results as we move forwards into acoustic testing. We're going to start using a single speaker in a bottom tri-corner. And the reason for this is because that is the worst position for a speaker ever in the room, because room modes terminate in corners and they will be the most kicked off, the most maximally excited when a speaker is in a corner. So why do we put a speaker there? Because we want to see the room modes with an actual in-room test. So we want to make them as bad as we can possibly make them. It's called maximally exciting your room modes, so you can easily see them or hear them in tests. So putting the speaker on the floor and in one of the front tri-corners is definitely the way to do that. Then what we've done is, you can see the tape on the floor. We've marked what's called a line of symmetry in the room. So we've measured the sidewall to sidewall dimension, which was 13 feet, and we've marked the exact center point, and we've aligned the left edge of this piece of masking tape with the center of the room. So this is what's called a line of symmetry. And then what we've done is we've marked several positions. So we've measured from the front wall to the 38% point of the room, which happened to be 3 feet. And we've marked that as LP1, which is listening position 1. And then we've marked forwards to 12 inches forward, so 2 feet through the room. And that's where the front edge of Thomas's desk will be. And then from LP1, the 38% point, we've marked 2 spots backwards of that, 10 inches and then another 10 inches back. And what we're gonna do next is the room mode listening test with Thomas sitting on a chair. And we're gonna use an online tone generator to generate nice slow sine sweeps. And we're gonna do a listening test. All right, I have all of this stuff, just so you know, on an acoustic testing checklist that's a PDF that is included as a download below this video. So I have some extra details in there about your room prep and your room setup. Make sure you grab that, download it, and follow it. Let's get into the test. So here's our tone generator. We're using onlinetonegenerator.com, which is a free tool. And we're setting up a sweep that is going to go from 10 to 500 hertz over 45 seconds. We're using a sine wave. And then what we're going to use is this free SPL meter, C-weighted SPL meter on the iPhone. And we're going to adjust the output volume on the sound card to get into the range of 75 to 80 dB or so SPL C-weighted. Why is that? That's because that is the actual mixing volume sound pressure level that is appropriate for this room. And I don't really need to use a super precise professional SPL meter here because we're just doing a really rough measurement. So let's kick this off and adjust our output. All right, so I've got Thomas seated on his mixing chair. He's directly over the line of symmetry. I've used the tape measure to have him adjust the chair height so that his ears are exactly 47 inches off the ground, which is how high the tip capsule of the testing mic is going to be. And then I've got pieces of tape that I've drawn out sideways to the 4 different positions that we are testing. LP1, the 38% point, forwards 12 inches, backwards 10 inches, backwards 20 inches. And then there's a little trick that works really well for both aligning the microphone capsule when you need to rough align it, or figuring out if Thomas's ears are over top of one of the correct points. This I got off Amazon. It's actually a pendulum. I got a package of them and I've just tied a string to it. And the point is it has a weight and it hangs directly downwards and it can go right over these positions. So Thomas, I'm gonna get you to come forwards, maybe 4 inches. Keep going. You can kind of look laterally and kind of see where this is. Nice, and we're just gonna line you up right over LP1. Let's come forwards another 2 inches. Perfect. We're nicely aligned, and that's gonna be our first test position. What I'm gonna have Thomas listen for is the effect of room modes or resonances in the room. There are going to be some frequencies that are going to jump out and sound really loud. There's going to be other frequencies that are going to sound quieter. And he's going to mark on a piece of paper the results of the listening test. Then we're going to repeat that at the other positions. 12 inches forwards of LP1, which is where the edge of the desk would be if it was pressed against the wall, and then 10 inches back from LP1, and then 20 inches back from LP1. And one of these positions is going to sound the flattest, the smoothest, and the most balanced modally. And that's the position we're looking for. Let's do it. So the position, based on our test, that sounded the worst was 12 inches forward of LP1, 12 inches forward of the 38% point, which is 2 feet from the front wall. That had huge jumpy resonances and nulls, so that was a clear, not gonna do that position. The position that sounded best was the furthest position back into the room, 20 inches behind LP1. But we scrubbed that because we're also balancing the priority of aesthetics in the room. And because it's such a small room, that just placed Thomas a little too close for comfort to what will be the back wall modules. And there wasn't enough access room around. It just felt wrong in the room. So the next 2 positions, LP1, the 38% point, and 10 inches behind that, both felt not perfect, but felt roughly equivalent to each other. So the position that we chose for the rough listening position, where we're going to align the measurement mic, is LP1, the 38% point. So now what we're going to do is we're going to get the mic in the room, and I'm going to show you how to align your measurement microphone. Let's go. So let's talk about mic measurement. And here is where I want you to be precious, because millimeters matter. Why is mic alignment super, super important? Because when you're doing speaker measurements with both speakers on, if there's even the slightest phase difference in time of flight between the left and the right speaker, you're gonna get horrible constructive and destructive interference, which will result in comb filtering. Even if you align the mic as precisely as humanly possible, you're gonna get comb filtering in the high end, but we wanna get it as close as possible. And you also want the mic position to be consistent amongst all of your measurements while we're in the build process. So the center of the mic capsule is going to be 47 inches off the floor. That's what traditional ear height is. I am going to align the capsule of the mic vertically over the LP1 position. So that's marked on the left edge of the masking tape. And there's 2 methods you can use. If you want the low-tech method, you can use that plumb bob on a string and just hover it in front of the mic capsule, and wherever it hangs, you get it over the top of that LP1 point. I have a self-leveling Milwaukee laser, and that's what I'm going to use because I want this to be as precise as possible. So I shine the bottom part of the laser on LP1 and I align so the very center of the mic capsule is just getting lit by the laser. There's a lot of different measurement mics. You want an Omni mic, it needs to be a free field mic typically. There's a lot of low cost measurement mics. I'm using the Mini DSP UMIC 1, which is a USB bus powered mic that doesn't need an audio interface. Super convenient, that's why I use it. You just plug it in over USB, Room EQ recognizes it immediately, and you're good to go. Then what we need to do is we get the speakers on stands and into position roughly, okay? With them roughly in position, then we get the measuring tape, and we measure 12 inches back from the listening position. If you measure from this point and you set your listening position as the equilateral triangle's apex, then you're basically telling the acoustics of the room that you have a big ear sitting in the middle of your forehead, which is not true, right? The sound actually has to hit our ears directly, and so the apex of the triangle needs to be behind our head by about 12 inches. 12 inches is what I use. Some people use 14 or slightly different numbers, but a foot behind your ears or behind your head is where you want to be. So we've measured 12 inches back, and we've marked this on the line of symmetry as the apex of the listening triangle. So now what we need to do is I used the laser again, and I glanced the acoustic axis of the speaker. So that's the center part of the speaker, and I want it right at the front, right where the membrane is. And I just set the laser up, and I glanced the front of the speaker with it, and I looked at where that was drawing on the floor. Okay, so it's going, luckily these have a little vent in the speaker stand, and I could see it was hitting the floor right there. And that's my measuring point that I want to make sure is equilateral between the two acoustic axes of the speakers and the apex of the triangle. So I measured that out, and it's 38 inches. So we have 38 inches from there to there, 38 inches from here to here, and 38 inches from here to the apex. And if you're gonna measure between your speakers, do so at your own risk, because it's really common for people to ding up their tweeters with a measuring tape, okay? So technically, this should be 38 inches exactly, but I kind of align the speakers, and I oftentimes measure from the floor. So that is our basic setup. And again, we have the speakers pushed as close to the wall as possible without touching the wall and without the stands touching the wall. And we have room for cable clearance, but otherwise they're as close to the wall as possible. And these are rear ported speakers, okay? And we've talked about that before. I'll keep talking about it again. Rear ports, as long as they have enough clearance that's equal to the diameter of the port, you're completely fine with having them in close proximity to the wall. These ports are like 2 to 3 inches in diameter, and they have ample enough space to breathe. The ports are not getting blocked or attenuated or disabled in the slightest.
I want to pause for a sec and talk about why I've pushed the speakers directly up against the wall as close as they can go, because there is a ton of really persistent but unfounded bad internet advice saying that you need to pull your speakers out from the wall. And this is just categorically not true. And what it does is it ruins your bass response. And in a music studio control room like this, the accuracy of your bass response is absolutely essential. So a few years ago, I did this video in partnership with SonarWorks called "Is This Mistake Ruining Your Acoustics?" And what I did in that video is I tested scientifically with acoustic testing. I showed the effect that happens when you bring your speakers out into the room on stands. And every single time in every room, this creates a big hole in the bass, and it's not ideal. And even though I did that and showed with scientific testing the impact, there's a lot of people who still argue about this because there's been so many, even speaker manufacturers, that recommend putting the speakers out on stands. So we're going to settle this issue once and for all. I'm going to play you some content from other people, other authorities, and I'm going to give you some quotes here that will hopefully substantiate why this is so important. Okay? So first, we're going to see a little clip from GIK Acoustics. These are some of the most knowledgeable people on the internet who are actually getting things right. Okay? So listen to what they say.
For smaller rooms, it's better to place the speaker as close to the front wall as possible without actually touching it. This will minimize any speaker boundary interference that you have, and then you can focus treatment around the speaker.
Okay, notice they're not putting any treatment behind the speaker, because that would cause the speaker to have to move away from the wall.
The further the speaker is from the wall, the lower the affected frequencies. So pulling the speaker out far enough to place acoustic treatment behind it often causes interference to dip below the effective range of the panel.
This is another piece from GIK Acoustics where they talk about the manufacturer recommendation to move speakers away from the wall and what it does to the bass.
People will say, "Oh, I don't know, man. I think they overtrap the room." It's like, no, it's literally not. It's not possible. People will put their speakers in the room and they'll set them a couple feet away from the wall, because that's what the speaker manufacturer said to do. And they go, man, I don't have any bass in here. I think we have too many bass traps. And it's like, why don't you push your speakers like really close to the wall? Oh, well, the manufacturer said, that's cool. Just push them close to the wall and move your desk forward a little bit and call me back. And they're like, oh, yeah, the bass is like right there. It sounds really cool. It's like, there's always some other problem. It's never because you have too much bass trapping. Period.
Okay. Now let's go a little further, and I want to show you a clip from one of my friends. This is Nicholas DiLorenzo, incredible mastering engineer, runs the channel Panorama Mixing and Mastering, and he was just recently building a new studio, and he was doing exactly this. He was testing the acoustic results of different speaker positions, and he tested with the speakers on the wall, and then he moved the speakers forwards, and this is what he noticed.
Now what we're going to do is I'm going to bring, this is risky, I'm going to bring the speakers closer in, so in towards me, because at the moment they're right up against the wall as far as I can, which is just makes it easier to manage interference, but I'm going to bring them closer to see if it tightens this up. So if I bring these in, nope, doing that fucking made it worse. So
okay, I'm going to keep going here. So there are two professional acousticians that have quoted on this. The first is Jens Ackland. He's one of the most prominent acoustician, studio designers, builders on Gearspace. And his quote here is that at low frequencies, it's beneficial to have the source close to the boundary to reduce SBIR issues. So SBIR being speaker boundary interference response, or the reflection of the rearward radiated bass off the front wall or side walls or ceiling and rejoining. So he's said the opposite of what a lot of audiophiles think, which is that in order to reduce SBIR, you move the speaker away from the boundary. No, he knows what he's talking about. He's putting the speaker close to the boundary because then you have the reflection in phase, and then you can just reduce it with a low shelf. Okay, finally, I'm going to quote Wes Lachaux here. Now, if you guys don't know Wes Lachaux, he and his company, Wes Lachaux Design Group, build more ground-up studios in the world than anyone else these days. And Wes Lachaux is literally the guy who came up with the 38% rule for positioning your speakers, okay? I personally chatted with Wes, and I asked him this question about should you ever bring your speakers away from the wall on stands. This is what he had to say. He says, all is won or lost in the bass. You can buy your focals or whatever, but you'll just be guessing with your bass. You can move them around for years, but you'll just create a new problem. You would always put your speakers against the wall unless you have a very deep room, 9 to 10 feet from the wall in a 30-foot deep room. Otherwise, no. Okay? So let's just put this issue to bed. Everyone agrees out there, everyone that I consider and respect their opinions, there's just a total convergence that the speakers go against the wall in terms of music studio, acoustics, and control rooms. If you're an audiophile in a living room, do whatever you want, but for music studios, this is how we set up the speakers. The one exception that I will say to that rule is if you are using a subwoofer. So if you're high passing your monitors, then they definitely can be out into the room on stands because the offending frequencies are in the bass that are going to cause that big hole that you saw. And if you're using a subwoofer, you can use that subwoofer to manage those low frequencies, but you'll also still have to contend with SBIR in the subwoofer, and it'll need to be positioned correctly. So the only exception to this rule is if you're using a sub, or if you're doing what I did in my room, which is building the speakers flush mounted into the front wall.
So now we bring another laser into play. So this is just a little handheld ranging laser. And I double check that the time of flight between each speaker and the mic capsule is going to be very, very, very tight tolerance. So I'll turn this bad boy on. I'll set it up into ranging mode. I'll point it at the acoustic axis of the speaker, which is midway between the bass and mid driver and the tweeter, and align it over the mic capsule without touching it. And I want to test both sides and ensure that I've done my math correctly and the measurements correctly, and the time of flight between the two speakers is the same or within a very, very, very close tolerance. You can do all this stuff by using a string. You can do all this stuff by using a tape measure. I use lasers because I have access to them and I just like that extra layer of precision. So the final thing I want to talk about is adjusting the toe in of the speakers. So the speakers have been towed in to approximately 30 degrees, and then I fine tune them. So before the mic would have even been in, I drop down and center myself to where the listening position is. And I just make sure that when I look either way at either speaker, it's dead on. And an easy way to tell that and visually fine tune these is to lean and make sure the point at which you can see the cabinet sides is even. So if I'm looking at a speaker and I can already see a cabinet edge, it means it needs to be towed in more. Okay, so now we've warmed the speakers up as well. We've had them running with a bit of music, so the speakers are warm, the circuitry's warm, and we're ready to run our baseline acoustic tests. Let's get into it.
In the next episode, we'll go deeper into the acoustic testing process. I'll show you Room EQ Wizard, which is the free app that I use for all of my room tests, and I'll walk you through the basics of how to use it to make scientific measurements of your studio.